Hello, greetings to everybody. I hope all of you are doing fine. This is your Professor Jun Cajigal, and welcome to another of our online lecture series on science, technology, and society. So for this video, we will be focusing on the contributions of the ancient Egyptian civilization and the ancient Greek civilization. So before we proceed with our lecture for today, don't forget to like and share this video so that we could reach more people, especially those students who are taking science, technology, and society. And don't forget also to subscribe to my YouTube channel, The Science Guy, Professor Jun Cajigal. Don't forget to subscribe and click on that notification bell so that you would be updated on our future online lectures. Alright, so let us now go and let's dig into the contributions of the ancient Egyptians and the ancient Greeks. Now, when we think of the ancient Egyptian civilization, we always associate the Egyptians with, you guess it, the pyramids. So, Egyptian engineers, they constructed those magnificent pyramids. And the ancient Egyptians, they were even quite famous in building those complex irrigation systems. But before we go into the details of the pyramids and the irrigation system of the ancient Egyptians, let's talk about the contributions of the Egyptians in terms of medicine and health. Alright, so religious beliefs dominated the ancient Egyptians' view of healing. So the Egyptians linked medicine, the healing of diseases, with their religious beliefs. In fact, doctors were often priests, and these priests, they were able to communicate with their gods responsible for the health of the different parts of the body. So, magdadasal sila sa kanilang mga Diyos. And these gods, these are animals. They worship animals as gods, and they even worship the heavenly bodies. So, itong mga doktor na ito, itong mga priests, doctors, they communicate with those gods so that the person who is sick will get healed. Now, why? Now, Egyptians, they believe that illness was due to the presence of evil spirits. So, ang dahilan daw kung bakit may sakit ng isang tao, kasi yung tao na yan ay may masamang spirito. So, in order to drive away the evil spirits, idadasalan nila yung may sakit. Alright, so removing these evil spirits from the body, they will do that with prayers to the gods that would cure the disease. So that's what they did in healing. So they communicated with their gods, and in order for them to drive evil spirits, because again they believe that illness was due to the presence of evil spirits. Kaya may sakit ang isang tao dahil naniniwala mga ancient Egyptians na sinasapian sila ng masamang spirito. So they will pray to the gods so that these evil spirits would be driven away from the body. So that's what they did. And medicines were used to help relieve pain, but were not thought to play any other role in the healing process. So yung mga gamot na ina-apply, pang pain reliever lang, but it has nothing to do with the healing process. So, in terms of worshiping gods, as I have mentioned earlier, they worship animals like the jackal. So, these Egyptian doctors and priests, They will pray to this god who resembles a jackal para gumaling yung pasyente. Because again, they believe that illness is due to the presence of these evil spirits. And again, many of these gods were animals like the heron. Yan, so sinamba nila yung heron as God. Alright, even the falcon was worshipped as God. Alright, so that's how we describe the contributions of the ancient Egyptians in terms of medicine and health. So you will notice that medicine, curing of diseases, was linked with their religious beliefs. Now, also in relation to medicine, the Egyptians gave to the world mummification, preserving their dead. So, in preserving the dead, let's say the dead pharaoh, they will have to remove the internal organs of the dead person and will place them in glass jars or glass containers. Then the person is embalmed with certain chemical concoctions. Then the body is wrapped in linen. And eventually, the body of, let's say, the pharaoh is placed in a coffin called a sarcophagus. Alright, so the ancient Egyptians gave to the world mummification. Again, in relation to medicine. Alright, so mummification was made by the ancient Egyptians. Alright, and with this, we can say that since they removed the internal organs during the mummification process, we can say that these ancient Egyptians, they were quite knowledgeable in the field of human anatomy. So they have thorough knowledge. They were experts in human anatomy. They are aware of the internal organs of a person. So they were quite knowledgeable in human anatomy. And in relation to this, they performed surgery. And with surgery, they came up or they invented certain surgical instruments. Alright, so that's the mummification and surgery and the invention of surgical instruments. Now, aside from medicine, the ancient Egyptians really made significant contributions in agriculture. Agriculture was defined by the ancient Egyptians. But there's a problem. Now, Egypt lies in a desert. So, in order to water their agricultural lands, these ancient Egyptians, they need to channel the water from the river Nile to their agricultural fields. So as you could see here in our map, that Egypt is close to the Sahara Desert. And in order to supply water to their agricultural fields, what the ancient Egyptians did is to channel that water from the river Nile by constructing a network of canals. And that's what they did. They constructed network of canals in order to channel the water from the river Nile to their agricultural fields. So the ancient Egyptians were quite famous for their complex irrigation system. But again, in our previous discussion about the Mesopotamians came up also with irrigation, but the Egyptians really made irrigation to a higher level. So they built huge network of canals in order to channel the water from the river Nile to their agricultural fields. So that's what they did. The Egyptians were quite famous in those complex irrigation systems. Alright, now let's talk about now the astronomy during the time of the ancient Egyptians. Now, the Egyptians believed that many of the stars and planets were actually gods and goddesses that they worship. So, sinamba nila yung mga yan. They were so fascinated by the movements of these heavenly bodies, and they worship them as gods and goddesses. In particular, they were drawn to these two bright stars that always could be seen circling the North Pole. So the Egyptians referred to those two stars as the indestructibles. So we have the following two stars. These are Chap. Chap is located in the bowl of the Little Dipper, and Mizar. Mizar is located at the middle of the handle of the Big Dipper. So as you could see here in our illustration, you have Chap. Chap is located in the bowl of the Little Dipper, and Mizar is located at the middle of the handle of the Big Dipper. So those are the two stars which the Egyptians referred to as indestructibles. And look, the star in between Chap and Mizar. That's Tuban. And there is an astronomical significance in that because Tuban was their North Star. Our North Star at the present time and age is Polaris. But during the time of the ancient Egyptians, it was Tuban. Now, why the sudden shift from Tuban to Polaris? Now, it has something to do with the wobbling effect of the Earth's rotation called precession. Now, because of the precession, as the Earth spins on its axis, there is a change or shift in the location or position of stars. So, around the time of the ancient Egyptians, their North Star was Tuban. Then, about 26,000 years later, at the present time, our North Star is Polaris. Then, probably 26,000 years into the future, we will have another North Star. Alright, so those were the indestructible stars, Chap and Mizar. And at the middle is Tuban, which was the North Star of the ancient Egyptians. But our North Star now is Polaris. Again, because of the wobbling effect of the Earth's rotation, or what we call as precession. Now, the astronomy of the ancient Egyptians is somewhat again associated with the Nile River because pharaohs and even the priests, they needed to predict the annual flooding of the River Nile. So the annual flooding of the Nile River was the foundation of Egyptian civilization and agriculture. So predicting the flooding of the River Nile with accuracy was the driving force behind the development of Egyptian astronomy. Now, we all know that Egypt lies in a desert. And pag tumaas yung water level ng Nile River, that's a good thing. Because pag tumaas yung water level, then more water can enter the canals. Pag maraming tubig sa kanilang irrigation system, that's good. Because the agricultural fields will be supplied with water. So that means more harvest. Hindi mamamatay yung kanilang plantation. Alright? As compared to hindi tumataas yung water level. So parang tagtuyot yan or drought. So it is important for the Egyptians to predict the annual flooding of the Nile River para dun sila magtatanim, and eventually that means good harvest. So predicting the flooding of the River Nile was the driving force behind the development of Egyptian astronomy. So you could see here that astronomy during the ancient Egyptians was intertwined with their religion. Alright, so in order to maintain power, The pharaohs and the priests used astronomy to predict the annual flooding of the Nile River. Siyempre, pag nape-predict mo yan, magiging Diyos ang turing sa iyo ng mga tao. Right? Mayroon kang kapangyarihan to predict. So, in that way, they can maintain power, especially yung mga pharaohs and yung mga priests. Alright? This yearly flooding was imperative so that the Egyptian civilization could survive in the dry African Sahara Desert. Alright? Early astronomers discovered that the flooding coincides with the rise of Sirius. Okay? So, we'll talk about that later. So, yung pag-rise ni Sirius, dyan nagko-coincide yung flooding ng Nile River. Alright, so that's the flooding of the River Nile. Very crucial in the agriculture of the ancient Egyptians. Now, in terms of the pyramids, the Egyptians, they aligned their pyramids and even their temples towards the north because the ancient Egyptians believed that their pharaoh would become stars in the northern sky after they died. So, very particular ang mga ancient Egyptians sa northern sky. Again, because they believe, naniniwala sila, pag namatay yung kanilang pharaoh, the pharaoh would become stars in the northern sky. So, the precise orientation of the Egyptian pyramids towards the northern sky affords a lasting demonstration of a high degree of technical skill in watching the heavens. So, talagang very precise yung orientation ng pyramids sa north. In fact, the entrance to the burial chamber is aligned with Tuban. Alright, so this will show that the ancient Egyptians were very skilled in astronomy. Alright, it has been shown that the pyramids were aligned towards the pole star, and that's Tuban. Alright, so even the entrance of the burial chamber is aligned towards the pole star. Alright, so the burial chamber, the entrance is aligned at Tuban, while the shaft is aligned at the belt of Orion, located in the Orion constellation. So this shows that the Egyptians were quite skilled in astronomy. Alright, the alignment of the pyramids towards the north will show that the Egyptians were quite skilled in astronomy. Alright, so the burial chamber, even the entrance to the burial chamber is pointing at Tuban, that's their North Star, and the shaft of the burial chamber is oriented to the Orion's belt. Alright, so the pyramids also are aligned or they are oriented to reflect the constellation Orion, with the three pyramids at Giza representing the belt of Orion. So the pyramids at Giza, the orientation of these pyramids represents the three stars at the Orion's belt. So isn't that fascinating? So these Egyptians were quite skilled in astronomy. Alright, so that's what they did. Okay. Now, let's talk about now some of the inventions that influenced and made an impact in our own society. So, the ancient Egyptians gave us metal making. At around 3000 BC, the Egyptians discovered that by mixing small amount of tin with copper ore, they could make bronze. So again, the Egyptian civilization actually overlaps with the Bronze Age. Bronze is harder and more durable than any other metal of the time. And this archaeological period became known as the Bronze Age. Bronze tools, weapons, armor, building materials, and decorative items have been found. Alright, so the Egyptians gave us metallurgy, metal making. So they were able to mix tin and copper to produce bronze. The ancient Egyptians also gave us writing. But we all know that the Mesopotamians gave the first system of writing called the cuneiform. The Egyptians gave us hieroglyphics. The ancient Egyptians were among the first group of people to write and to keep records. The earliest form of Egyptian writing was the so-called hieroglyphics, which combined with holographic, syllabic, and alphabetic elements and had some about 1,000 distinct characters. So the Egyptians gave us the hieroglyphic system of writing so that they can document and keep records of their activities and astronomical events. The Egyptians also gave us the first paper made of papyrus. The ancient Egyptians learned the pith of the plant Cyperus papyrus, which found throughout the Mediterranean region, and they made that into sheets that could be rolled into scrolls. Ayan, so binigyan tayo ng papel ng mga Egyptians. But again, the Chinese gave a more durable type of paper made of bamboo. But it was the Egyptians who gave us the first paper made of papyrus. And in relation to papyrus, the Egyptians also gave us ink. Having papyrus to write on would have been useless without the invention of the ink. So, coinciding with the invention of papyrus paper, ang mga Egyptians, syempre, nag-invento sila ng ink. The ancient Egyptians mixed vegetable gum, soot, and beeswax to make black ink. Eventually, they replaced the soot with other materials such as red ochre to create various ink colors. And also coinciding with ink, the ancient Egyptians also gave us makeup. So, pag nagme-makeup yung ating mga ladies, alam niyo na, the makeup was first made by the ancient Egyptians. Also, the ancient Egyptians gave us the ox-drawn plow and the sickle. Though the plow was introduced by the Mesopotamians, the Mesopotamian plow was made of wood, wooden plow yan. But the Egyptian plow was made of bronze. Alright, the first ox-drawn plows appeared in Egypt as early as 2500 BC, and they were made of bronze. So, pag bakal yung plow, mas madali nilang bungkalin yung lupa. So, the bronze plow made cultivation quite easy. No? So, it easily scored the earth into furrows. And then workers with hoes then broke up the clumps of soil and sowed rows with seeds. So, napadali ang kanilang agriculture using that metal or bronze plow. Alright? So, they did this along the fertile banks of the Nile River where the ancient Egyptians grew wheat and various vegetables. Alright, the ancient Egyptians also gave us clocks. The Egyptians used their famous obelisk, yung mga matutulis na monuments, and they made sundials out of them. So yung mga matataas na obelisk, they used that to keep track and monitor the movement of the sun so that they can determine the hour of the day. So from this, the ancient Egyptians were able to determine the longest and shortest days of the year. So, yung clock nila is in the form of sundial. Now, by observing the the shadow cast by the obelisk, yung mga matataas na matutulis na monuments. Like that in Washington, D.C. Di ba may obelisk dun sa Washington, D.C. So the Egyptians were able to determine time. And because of these clocks, the ancient Egyptians came up with the calendar. The Egyptians devised their highly accurate solar calendar by recording the yearly reappearance of Sirius in the eastern sky. When Sirius rose, pag umangat na yung Sirius, at will coincide with the yearly flooding of the River Nile. And using the obelisk, yung mga sundials nila, they monitored, they kept track of the movements of the sun. So they came up with a calendar made of 365 days, and they divided 12 months of the year, and each month had 30 days. And there were 5 festival days at the end of each year. So the Egyptians gave us the calendar. Alright, so here is an illustration of their calendar with 12 months. And each month is divided into 30 days. Alright, the Egyptians also gave us toothpaste. The ancient Egyptians invented toothpaste with one recipe containing powdered ox hooves. Yan, dinikdik yan na ox hooves. Kasi ang ox hooves, pag dinikdik yan, abrasive yan. So magandang ingredient yan for toothpaste. Ashes, burnt eggshells, and pumice. No, ang pumice, ano yan? Volcanic rock yan. And pumice, may mga crystals yan. So, magandang abrasive material for toothpaste. Alright? Then, kasi hindi naman mabango yung toothpaste. So, they added certain ingredients like mint, rock salt, iris flower, and grains of pepper para naman mabango yung kanilang toothpaste. So, pag nag-toothbrush kayo, nilagyan nyo ng toothpaste, isipin ninyo, ancient Egyptians gave the toothpaste. And like what I mentioned earlier, since they were engaged in mummification, the Egyptians gave us surgical instruments. The Egyptians invented medical surgery. Yan, and they used instruments, no, like flint, swab, bandage, adhesive plaster, surgical stitches, and cauterization. So these are just some of the surgical instruments that the ancient Egyptians used to perform mummification and surgical procedures. Alright, so isn't that fascinating indeed about the contributions of the ancient Egyptians?
There may be no greater tribute to a society's ingenuity and vision than Egypt's Great Pyramid of Giza, originally standing 481 feet tall. The Great Pyramid towers over monuments like the Statue of Liberty and Big Ben. Of course, the pyramids are only part of ancient Egypt's legacy. Over the thousands of years, ancient Egyptians also thrived as inventors, and as you'll see in this list of amazing Egyptian inventions, their creations changed everything, from fashion to agriculture, so drastically that we still see their influence today. Toothpaste. The Egyptians had a lot of trouble with their teeth, in large part because their bread had grit and sand in it, which wore out their enamel. While they didn't have dentistry, they did make some effort to keep their teeth clean. Therefore, contributed to innovation to dental hygiene, in the form of toothpaste. The composition of toothpaste was recorded in ancient Egyptian scripts. Early ingredients included the powder of ox hooves, ashes, burnt eggshells and pumice, which probably made for a less than refreshing morning tooth care ritual. Breath mints. Bad breath in ancient Egypt often was a symptom of poor dental health. Unlike us, The Egyptians didn't gorge on sugary soft drinks and foods that contribute to tooth decay, but the stones they used to grind flour for bread contributed a lot of sand and grit to their diet, which wore down tooth enamel to expose the pulp of the tooth, making it vulnerable to infection. The Egyptians had specialists for many medical problems, but unfortunately, they didn't have dentists or oral surgeons to fix their deteriorating teeth and gums. Instead, they simply suffered, and scientists who've examined mummies have found severely worn teeth and evidence of abscesses, even in youthful Egyptians. To cope with the unpleasant odors from their rotting mouths, Egyptians invented the first mints, which were a combination of frankincense, myrrh, and cinnamon boiled with honey and shaped into pellets.
Well done.
Eye makeup. The Egyptians believed that eye makeup will help people become a longevity. Since they first invented eye makeup as far back as 4000 BC, it's never gone out of style. Even more impressive, some cosmetically minded cultures still create makeup using the same techniques pioneered by the Egyptians thousands of years ago. They combine soot with a mineral called galena to create kohl, a black ointment that is still popular today. They also make their eyes green by combining a mineral malachite with galena. For ancient Egyptians, it was not just women who needed makeup. In their society, the appearance represents the social status. So the higher the social status, the more elaborate the makeup. Fashion was only part of the reason for the Egyptians' notoriously heavy hand when applying eyeliner. They also believed that applying a thick coating of the stuff could cure various eye diseases, and even keep them from falling victim to the evil eye. Papyrus sheets. No one denies that the Chinese changed the world with the invention of paper around 140 BC, but what many people don't know is that the Egyptians had developed an admirable substitute thousands of years earlier, from the papyrus plant. Papyrus paper is brown, hard, but bendable, and extremely durable, made from the core of a papyrus plant, about 2-3 meters high that grows on the banks of the Nile. Its tough, fibrous interior proved ideal for making durable sheets of writing material, along with sails, sandals, mats and other necessities of ancient Egyptian life. After the sheets were made, they were often combined into scrolls, which were then filled with everything from religious texts to literature and even music. Ancient Egyptians kept the time-consuming process of manufacturing papyrus a closely guarded secret, allowing them to trade papyrus sheets throughout the region. Written language. The Egyptian writing system is hieroglyphic system, first appearing in 6000 BC. Pictographs are simple descriptions of the words they represent, but there are certain limitations. Over time, the Egyptians added a number of other factors to their writing system, including letters like the alphabet representing certain sounds and other characters, allowing them to write down their names and abstract concepts. Today, everyone knows Egyptians for the creation of hieroglyphics, which contained a mixture of alphabetic, syllabic symbols, as well as ideograms. Pictures that stood for whole words, found widely in Egyptian tombs and many other places. The writing tells tales of war, politics and culture that give us a great understanding of ancient Egyptian society.
Now at this point, let us now go into the details of the contributions of the ancient Greek civilization. Now, how do we describe the ancient Greek civilization? Now, the ancient Greek civilization was a period of political, philosophical, artistic, and scientific achievements that formed a legacy with unparalleled influence. In short, the Greeks gave us science. The Greeks separated religion from the study of nature. Now, if you will recall, the Mesopotamians and even the Egyptians, they linked the study of nature with their religion. This time, the Greeks separated religion from the study of nature. The Greeks made important contributions to philosophy, mathematics, astronomy, and even medicine. Literature and theater was an important aspect of Greek culture and influenced modern drama. The Greeks were also known for their sophisticated sculpture and architecture. In short, the Greeks separated religion from philosophy, mathematics, astronomy, medicine, and so forth. The Greeks gave us science. Alright, now let's talk about now some of the early ideas of the Greeks about the heavens. Now, the ancient Greeks made use of models and observations in order to explain the workings of the heavens. Through the use of models and observations, the ancient Greek astronomers were the first to use a careful and systematic manner to explain the workings of the heavens. Also, the Greeks made instruments because we all know that the telescope was not yet invented, so the Greeks was limited to their naked eye observation. So they made instruments to aid in their naked eye observations. Also, the Greeks made use of logic and mathematics as tools for investigating the heavens. And this was one of the early astronomical instruments that the Greeks made. This is called the astrolabe. The astrolabe is the precursor of the modern sextant that allows the Greeks to track the position of heavenly bodies. So that's the astrolabe. And like what I mentioned earlier, the Greeks made use of models to explain the workings of the heavens, like this one made by Eudoxus. So this was a simulator to explain the motion of the planets. And this was devised by Eudoxus of Knidos, who tried to simulate the irregular motion of the planets using this model. And Eudoxus came up with a model of the solar system by placing the Earth at the center. So Eudoxus created a model of a geocentric universe that's around 380 BC. So he designed his model of the universe as a series of cosmic spheres containing the stars, the sun, and the moon, all built around the Earth at the center. So it was Eudoxus who came up with the first geocentric model of the solar system by placing the Earth at the center, and the Earth is surrounded by a series of cosmic spheres containing the stars, the sun, the moon, and other heavenly bodies. But there was a problem. Eudoxus cannot explain the movement of Mars. So that was the problem of Eudoxus in his geocentric model. Eudoxus cannot explain the unusual movement of Mars. Now, since Eudoxus cannot explain the unusual movement of Mars, another astronomer came into the picture, and that was Aristotle. Though Aristotle was already given the title as the father of biology, Aristotle was also an astronomer. Aristotle actually gave us the first system of classifying living things. Animals were classified according to their habitats, while plants were classified according to the stem structure. But nonetheless, Aristotle gave significant contributions to astronomy. In fact, Aristotle borrowed from the idea of crystalline spheres from the Eudoxus geocentric model. The sun, the moon, and each of the planets, they have their own crystalline sphere similar to that of Eudoxus, but the outer sphere carried all the stars. So that was a refinement of the model made by Eudoxus. Alright, so this was Aristotle's geocentric model of the universe. But again, just like Eudoxus, Aristotle encountered the same problem. Aristotle cannot explain the unusual movement of Mars. Alright, so before we move on to the next Greek astronomer who refined the geocentric model, let's talk about the contribution of Eratosthenes. Now, Eratosthenes gave us the value of the Earth's circumference. He first calculated the circumference of the Earth. Alright, so this is how Eratosthenes calculated the Earth's circumference. So Eratosthenes heard about a famous well in the Egyptian city of Syene on the Nile River. At noon one day each year during the summer solstice, that is between June 20 and June 22, the sun's rays shone straight down into the deep well. They illuminated only the water at the bottom, but not the sides of the well as any other day. So can you take a look at this photo of that well? So there are no shadow along the sides. So that means that the sun is directly overhead during summer solstice, proving that the sun was directly overhead. Then, in another city in Alexandria, Eratosthenes erected a pole in Alexandria. And on the summer solstice, he observed that it cast a shadow, proving that the sun was not directly overhead, but slightly south. So this would mean one thing. So no shadow in Syene, but there's a shadow in Alexandria. It means that the earth is curved. Recognizing the curvature of the earth and knowing the distance between the two cities enabled Eratosthenes to calculate the planet's circumference. And let us watch this video of Carl Sagan. This is from the episode Cosmos. Let's watch the explanation. Let's listen to Carl Sagan on how Eratosthenes calculated the Earth's circumference. Okay, let's watch this. Cosmos by Carl Sagan.
There was once a time when our little planet seemed immense, when it was the only world we could explore. Its true size was first worked out in a simple and ingenious way by a man who lived here in Egypt in the 3rd century BC. This tower may have been a communications tower, part of a network running along the North African coast by which signal bonfires were used to communicate messages of state. It also may have been used as a lighthouse, a navigational beacon for sailing ships out there in the Mediterranean Sea. It is about 50 kilometers west of what was once one of the great cities of the world, Alexandria. In Alexandria at that time, there lived a man named Eratosthenes. One of his envious contemporaries called him Beta, the second letter of the Greek alphabet, because he said Eratosthenes was second best in the world in everything. But it seems clear that in many fields, Eratosthenes was alpha. He was an astronomer, historian, geographer, philosopher, poet, theater critic, and mathematician. He was also the chief librarian of the great Library of Alexandria. And one day, while reading a papyrus book in the library, he came upon a curious account. Far to the south, he read, at the frontier outpost of Syene, something notable could be seen on the longest day of the year. On June 21st, the shadows of a temple column or a vertical stick would grow shorter as noon approached. And as the hours crept towards midday, the sun's rays would slither down the sides of a deep well, which on other days would remain in shadow. And then, precisely at noon, columns would cast no shadows, and the sun would shine directly down into the water of the well. At that moment, the sun was exactly overhead. It was an observation that someone else might easily have ignored. Sticks, shadows, reflections in wells, the position of the sun, simple, everyday matters of what possible importance might they be. But Eratosthenes was a scientist, and his contemplation of these homely matters changed the world, in a way, made the world. Because Eratosthenes had the presence of mind to experiment, to actually ask whether, back here, near Alexandria, a stick cast a shadow near noon on June the 21st. And it turns out, sticks do. An overly skeptical person might have said that the report from Syene was in error, but it's an absolutely straightforward observation. Why would anyone lie on such a trivial matter? Eratosthenes asked himself how it could be that at the same moment, a stick in Syene would cast no shadow, and a stick in Alexandria, 800 kilometers to the north, would cast a very definite shadow. Here's a map of ancient Egypt. I've inserted two sticks or obelisks, one up here in Alexandria and one down here in Syene. Now, if at a certain moment each stick casts no shadow at all, that's perfectly easy to understand, provided the earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the earth. Sticks at different angles to the sun's rays will cast shadows at different lengths. For the observed difference in these shadow lengths, the distance between Alexandria and Syene had to be about 7 degrees along the surface of the earth. By that I mean, if you imagine these sticks extending all the way down to the center of the earth, they would there intersect at an angle of about 7 degrees. Well, 7 degrees is something like a 50th of the full circumference of the earth, 360 degrees. Eratosthenes knew the distance between Alexandria and Syene. He knew it was 800 kilometers. Why? Because he hired a man to pace out the entire distance so that he could perform the calculation I'm talking about. Now, 800 kilometers times 50 is 40,000 kilometers. So that must be the circumference of the earth. That's how far it is to go once around the earth. That's the right answer. Eratosthenes' only tools were sticks, eyes, feet, and brains, plus a zest for
for experiment. With those tools, he correctly deduced the circumference of the Earth to high precision, with an error of only a few percent. That's pretty good figuring for 2,200 years ago.
Alright, so that video of Carl Sagan was quite fascinating indeed. And Carl Sagan was able to explain how Eratosthenes was able to calculate the circumference of the Earth. Alright, so at this point, let's talk about now the contribution of Claudius Ptolemy. Now, Claudius Ptolemy also constructed a model of the geocentric universe. So he placed the Earth at the center. As usual, we have those cosmic spheres, and in each cosmic sphere are the heavenly bodies, the sun, the moon, and the 5 visible planets. And also Ptolemy encountered the same problem about Mars. So Ptolemy had a difficulty explaining the movement of Mars. But you know what? Ptolemy provided a solution. He was able to explain the unusual movement of Mars. Now, what is this unusual movement of Mars? So Mars would move from west to east, then Mars would move backwards, back towards the west, and then would proceed eastward. Alright, so the planet moves from west to east, then the planet makes a U-turn, and then goes back eastward. So this unusual movement of Mars is known as retrograde motion. Alright, so that's the unusual movement of the planet Mars. So Mars would move from west to east, then Mars would make a U-turn, and then proceeds to its normal direction. So this is what we call retrograde motion. Alright, and Ptolemy was able to explain retrograde motion simply by including epicycles. So as the planets revolve around the Earth, the planets also moves in a circular motion as one depicted in this animation. So as the planet moves around the Earth, and the Earth is at the center, the planet moves also in a circular fashion. So from our perspective here on Earth, we could see Mars moving in a retrograde motion. Alright? So the inclusion of epicycles provided the solution for the retrograde motion of Mars. So quite fascinating indeed. And this inclusion of the epicycles made the geocentric model the standard model of the universe. The inclusion of epicycles in the geocentric model solved the problem of retrograde motion of Mars. And this has become the standard model of the universe.
However, Claudius Ptolemy was careful to compile much of that work and published his ideas in something called the Almagest, the greatest. In other words, he was paying tribute to the greats that had come before him. So he was able to popularize the idea of the geocentric model. Again, this was the prevailing idea of the ancient Greeks. It seemed to make the most sense despite a few dissenters, and it was also Ptolemy who gave the first explanation for something called retrograde motion. And this idea would dominate for over 1,500 years, well into the next millennium. Let's talk a little bit about retrograde motion for a moment. Retrograde motion is simply the apparent shift in the position of the planets. So given a planet's normal tendency, it will seem to go eastward or prograde, but then once in a while the planet will appear to backtrack. This is the retrograde motion before resuming its prograde motion once again. Now, for everything to rise in the east and set in the west, it would be perfectly reasonable to conclude that the Earth was at the center of the cosmos. But this retrograde motion was an anomaly. It did not make sense. So, in order to make the retrograde motion work, rather than having Mars in this example and all of the planets directly revolving around the Earth, Ptolemy introduced a new concept called the epicycle. The epicycle was an invisible circle that carried Mars, and the epicycle itself revolved around something called a deferent, and it would be this epicycle moving about the deferent that would create the apparent retrograde motion. So you can imagine yourself on Earth looking at Mars, and it appears to be going in prograde motion before executing a slight zigzag back and forth in the sky, giving us retrograde motion. Now, this was a good first order approximation. But the problem, though, is that the epicycle that we see here just would not be accurate enough to predict when the next retrograde motions would be. To solve this problem, Ptolemy introduced a modification to his ideas. He introduced a equant, that is, the Earth is still very much at the center of the cosmos. But the epicycle, the deferent, and so forth, now were centered on an offset point called an equant, and this is what helped to make the retrograde motion of Mars and all of the planets be a little bit more on time, do a slightly better job of predicting exactly when these retrogrades would occur. Even then, sometimes additional modifications would be required, not the least of which was adding an additional epicycle to the epicycle. And things got a little bit complex over time. And this was a major problem because while the epicycle model did an extremely good job of predicting retrograde motions for about 1500 years, it was at the same time a little bit messy, and it allowed some people to begin to think maybe there were alternatives and maybe some of these ideas to the geocentric model should be revisited.
Alright, so I guess we have to end this video and we will continue with the contributions of the Greeks. So before we end with this video about Ptolemy's contribution and his geocentric model of the universe, which will then be contradicted during the Renaissance era by Copernicus, please don't forget to like and share this video so that we could reach more people, especially the students out there who are taking science, technology, and society. And don't forget also to follow me on my Facebook page and my YouTube channel, The Science Guy, Professor Cajigal. Don't forget to subscribe and click on that notification bell so that you would be updated on my future online lectures. So in our next video, we shall continue with the Greeks and with the Roman civilization. Alright, so live long and prosper, and see you in my next video. Bye-bye!